This is Geometry, Lesson 8-3, Solving Right Triangles Using Trigonometry. First, I want to start with some tricks with fractions. So the old-fashioned way of solving a fraction equal to another fraction is to undo the thing that's happening to x. In this case, x is being divided by 2. The opposite of divide by 2 is to multiply by 2, and we'd say multiply by 2 on both sides, and then these 2's would cross-cancel, and that is mathematically correct. I want to show you a faster way while still showing your work. So this 2 can just move up here. These diagonals are freely exchangeable. I could move this x down in the bottom right. I could move this 7 up to the top left. I can move this 3 to the bottom left. I can move this 2 to the top right. I can do any one of those 4 operations freely. So in this case, moving 2 to the top right gets x by itself, and you're done. You can say, okay, your new fraction is x by itself is equal to 3 times 2 in the numerator and 7 in the denominator. And you can say x is equal to 6/7 for your final answer. So similarly, you'll have a problem where x is trapped in the denominator, and to get it out of the denominator, we can move it diagonally to the top right. So here are all the operations I'm going to do. I'm going to move this x to the top right, and now in my mind's eye, I see this as 3x, and I want to move this 3 and move this 7 away so that x is by itself. So if I'm moving the 3 and moving the 7 away, that means that the 3 is going to move down here, and the 7 is going to move up here. I realize this is a lot of arrows, but I can see very clearly that x is going to be in the top right, and then I'm going to have a 2 and a 7 in the top left. So it's going to be 2 times 7 in the top left. And in the bottom left down here, I'm just going to have this 3. And there's my final answer. I can simplify this, of course. I can say that x is equal to a 14/3 for my final answer. So we're going to be using this diagonal trick quite a bit in this lesson. Let's see number 1. Find the missing side length, and we're going to round to the nearest tenth. And I don't know why I spelled tenth that way. It's a little bit annoying. I want to fix that here. Can I grab this thing and say tenth? T-E-N-T-H. There we go. Much better. That means 1 decimal place. If you didn't know this, this is the same thing as 1 decimal place. All right, so every single problem that we have in this unit is setting up SOHCAHTOA, setting up our trigonometry. So I will write out SOHCAHTOA to the side because we're going to use it over and over again. SOHCAHTOA. All right, so let's go ahead and label all the parts of my triangle. I know that the opposite of this angle of reference is going to be the opposite side. I'm going to label that O. I know that the opposite of the 90-degree angle is always going to be the hypotenuse. I'll label that H for hypotenuse, and by process of elimination, my adjacent side is the remaining length. Notice that there is no information given about the adjacent side, which means we are not using the adjacent side. We are not using the adjacent side, not using the adjacent side. The only syllable, I guess, the only part of SOHCAHTOA that we are not crossing off is the SO part of SOHCAHTOA, which means we're going to be using the sine function. So I'm going to write out sine of my angle. In this case, I have an angle. In the last case, in our last lesson, we didn't know what the angle was, and we called it theta, but we know what the angle is this time. 63 is our angle. We can say sine of this 63 degrees. And this is going to be equal to the fraction opposite divided by the hypotenuse. Opposite is x, hypotenuse is 12, so this is going to be x over 12. And from here, I just need to solve. So sine of 63 is something that I will eventually be putting on my calculator. But before I do on the calculator, I want to solve for x. Notice that I don't have a fraction equal to a fraction, so I'm going to envision a fraction equal to a fraction. I'm going to make this over 1. And now I see, yes, fraction is equal to fraction. And to get x by itself, 12 is going to move into the top right. Be very careful here, because the most common mistake that I see on this problem is willy-nilly putting the 12 wherever you want. 12 cannot go inside of the 63. 12 goes out front or behind, outside the parentheses. It never goes inside the parentheses, so be careful. The answer here, 12 is going to move to the top left, meaning that I have 12 sine of 63 degrees is equal to x. And there's my answer. So I just need to open up my calculator. Let me go and open that up. I like it on this side. All right, so I'm going to type in 12 sine of 63. Make sure that I'm in degrees, not radians. And there's my answer. So I can say my answer, x is approximately, and then where are we running? To the nearest one decimal place, or the nearest tenth. So I have 10.69, and that's going to turn into a 10.7. So this is going to be 10.7 for my final answer. And one final thing that you should really do is do a sanity check. Does that make sense in the context of the question? 10.7 is supposed to be for this length right here, and I mean that length was 12, so it's about 12-ish. That would make sense. If I randomly got like a length of 100 down here, that would not make sense. That's too big. And if I randomly got a length of like 1, that would be way too small. So that feels just about right, that Goldilocks zone, right? All right, then we move on to example 2. I'll bring back the calculator when we need it. For now, let's go ahead and set up our trig function. Again, using SOHCAHTOA, SOHCAHTOA for SOHCAHTOA. Let's go ahead and label our triangle. On the opposite side of our angle of reference, we have our opposite. On the opposite side of the 90 degrees, we have our hypotenuse, and that means that the 10 is our adjacent. Notice we have no information about our opposite side, therefore we are not going to be using the opposite side in this case. Cross off all the O's, leaving behind the CAH, the ka of the SOHCAHTOA, meaning we are using cosine. So set it up. I'm going to say cosine of my angle, in this case 21 degrees, is equal to my adjacent divided by the hypotenuse. My adjacent is 10, my hypotenuse is x. And notice that in this scenario, my x does not live in the numerator, it lives in the denominator, which means I need to move it into the numerator. Remember that this is really a fraction equal to a fraction, so I really have divided by 1 here. You don't have to write this. You can just ignore that and think of it as a fraction. This x is going to move up to the top right, and I don't want anything else with the x, which means this cosine of 21 needs to live in the bottom right. So I'm going to switch both of those. I'm going to say this x is going to live up here, and this cosine of 21 is going to live down here. So my final fraction is going to look like this. X over 1, or just x, is going to be equal to 10 divided by cosine of 21 degrees. And let's go ahead and approximate that. I can say that x in this case is going to be about, I need my calculator back, so let's go ahead and open that back up. So I'm going to type in, oh, not in here though, enter 10 divided by cosine of 21. Cosine of 21. And I get 10.7. 10.7. Again, you should do a sanity check to make sure that this actually makes sense. So in the context of the question, I mean, it should be around 10-ish, and that number is definitely around 10-ish. Remember, if this angle was 0 and it completely collapsed, and this length would be the same, the fact that there's a little bit of extra room means we have a little bit of extra length over 10, right? All right, finally, example 3. Again, set up our trig function by using SOHCAHTOA, SOHCAHTOA for SOHCAHTOA. Let's label our triangle. On the opposite side of our angle of reference, we have our opposite side. On the opposite side of our 90-degree angle, we have our hypotenuse. And therefore, by process of elimination, the x is our adjacent. So notice we have no information on the hypotenuse. So I'm going to cross off. We're not using the hypotenuse. All these h's we're crossing off, leaving behind the toa syllable of SOHCAHTOA. So from here, I'm going to write out our trig function. I have tangent of our angle. Our angle in this case is 57 degrees. And that's going to be equal to our opposite divided by our adjacent. So the opposite in this case is 87. Our adjacent is x. And again, this is one of those scenarios where I need to switch my x and my tangent of 57. I'm not going to write the divide by 1 in this case because I think you guys are old enough and smart enough to know that there is a divide by 1 here. I'm just going to go ahead and switch these two. I'm going to do this little arrow to show I am just going to switch those, and I'm going to get x is equal to 87 divided by tangent of 57 degrees. And then I just need to type that into my calculator to get an approximation for x. Let's open up the calculator once again. And I'm going to type in 87 divided by tangent of 57. And this answer rounded to one decimal place. It's 56.49. That's going to be rounded up to 56.5. 56.5, and box it. Excellent. Let's zoom out and see what we've got. That concludes lesson 8-3 for geometry's solving right triangles. Thanks for watching.